So I'm just starting the recording as well.
Okay.
So yeah, should we just get started? Everything fine now? And Kishore is also here. So yeah, I think we'll just get started with the workshop and then let's see. So hi Kishore, hi Satar. Okay.
Hi. Hello.
Hi. Yeah. So we're just getting started with the workshop then.
Yeah.
Yeah, sure. Yeah. Hello everyone. I'm Noor, one of the organizers at ISDAIOT Symposium. This is the second session of the Data Analytics Workshop in the ISDAIOT Symposium, where we discuss data preprocessing and visualization. This workshop is organized as 4 sessions on Thursdays of every week from 5 to 7 p.m. and is being supported by the IEEE Victorian section and the Student Engagement Grants Program at the University of Melbourne. Before we continue for today, I want to let you know that we have some quick coding contests on HackerRank from next week, where you can grab some prizes based on your coding performance. Don't miss them. Also, please attend the sessions and do participate in the hackathon to get a certificate. The YouTube link for the last week's video will be shared in the chat. Also, Sourav, again, an academic researcher at the University of Melbourne, is the workshop co-chair and who will be handling the session today. I'll leave the stage to Sourav and see you again towards the end of the session after HackerRank. Thank you. Over to you, Sourav.
Yeah, thank you, Krishma.
Yeah.
Okay. Good evening, everyone. Welcome to the second session of ISDAIOT workshop. So far, this is the outline of the workshop as discussed in the session 1. So today we are going to start the session 2, which is data preprocessing and visualization. So this is our brief outline of the session. So here some of the questions that we'll be able to answer after the end of this session, hopefully, like what are the essential Python libraries for data preprocessing or processing. Okay, then how to preprocess data with Pandas. So Pandas is one of the Python libraries that is very much useful, especially to handle large data sets. So we'll get some functionalities of this library, but we'll not get into too much details of Pandas in this session. We'll do it more on Pandas on the next session. So this session will keep our focus on the Numpy library. So we'll get to know more about the Numpy library, and also we'll use another 2 libraries, which is Scipy and Matplotlib libraries. So this is a brief idea on data preprocessing. So by preprocessing, we refer to the transformations applied to our data before feeding it to any data analysis algorithm. So data analysis algorithm can be some statistical analysis or some machine learning algorithm, but the data preprocessing technique which we refer is that is mostly used to convert the raw data into a clean and meaningful data set, because most of the data that we get in practice, they are not in a very structured way, and some data may be missing, and some other problems can exist. So we need to format the data so that we can feed into the algorithm, because algorithms are designed to have data in a certain structures, so that it can give the output in some structure. So to maintain that, we need to do some preprocessing. So the basic need is that of this data preprocessing is we need to have a structured data format to achieve a better result from the applied machine learning model, and also the dataset adaptability for various machine learning and deep learning algorithms to simultaneously study different models. So sometimes it happens that we need to explore different machine learning and deep learning models also, so that we can check the performance with various machine learning and deep learning algorithms. So the brief flow diagram is indicated by this diagram is here. Like the very first we get this raw data. From there we can structure the data, and next we can do data pre-processing. This pre-processing helps us to explore the data for further analysis, and from there we can get insights and generate some reports and make some plots by using graphs. So all these things we can do using various Python libraries. So what are the libraries that are useful here? So first is Pandas. So that is, as I said, is mostly for handling data sets. Then there is this NumPy. So NumPy is a Python library which is mainly used to handle various structured data. Then SciPy is for many scientific operations. We'll see their details in this session. And Matplotlib is mostly it is used for various plots. Those of you who have used MATLAB, you will see that there is a lot of similarities with this library and MATLAB plots. So first, a brief introduction or brief idea about data preprocessing using Pandas. So what is Pandas? Obviously, is the first question. So Pandas is an open source Python library that provides high performance data manipulation and analysis tool. So by using this Panda, we can typically accomplish 5 processing and analysis steps, so regardless of the origin of data. So we can load, prepare, manipulate, model, and analyze. So this library helps us to not just our user defined data. We can load data from any CSV file or Excel file. So this library is very useful for this kind of jobs. Then data structures used by Pandas are mainly a series, a data frame, and a panel. So a series, as the name suggests, is a one-dimensional data. So we can store the data is like in a sequential manner. Then data frame is a 2D data structure, so like a table or a matrix. And then panel is like a 3D data structure. So some of the primary features of Pandas as we go through. So it is very fast and efficient. It provides a very fast and efficient data frame object with default and customizing indexing. So we'll see that how we can use very much customized indexing with the data. Then it provides tools for loading data into in-memory data objects from different file formats. So it's very much flexible with different file formats, data alignment and integrated handling of missing data. So that is one of the key aspects that sometimes we need to do while structuring the raw data. Then reshaping and pivoting of data sets. So sometimes we receive data in one format, then we need to reshape the structure of the data. Like we have, say, received a single sequence of data, for example, 1 by 10, and we can reshape this data into like 2 separate arrays of 5 by 5. So these kind of things we can do by using Panda. Then there are label-based slicing, indexing, and subsetting of large data sets. The columns from a data structure can be deleted and inserted very efficiently. So the data can be grouped for aggregation and transformation, and high performance merging and joining of data is also provided by Pandas. And there is this time series functionality. So like a data can be stored as a time series. So that means it's like a sequence of data, but each data point is associated with a timestamp. Okay. Now let's get introduced to NumPy. So the first question is again, what is NumPy? So it is another Python library mainly used for working with arrays. It has various functions for working in domains of linear algebra, Fourier transforms, and matrices. So those mathematical or numerical operations that we largely do by using Python library we can handle very efficiently by using NumPy. So it's actually stands for numerical Python, because it's mainly designed for handling the numerical operations. So what are the operations that NumPy can handle are largely mathematical and logical operations on arrays. There are Fourier transforms and other routines for various types of manipulation of the structure of data. Then there are linear algebra related functions are there, and random number generations also there. These are for some statistical analysis. So the next question that comes in our mind, that why is NumPy faster than list? So list is a data structure that you have already seen in our previous session. So the NumPy arrays, they are stored at one continuous place in memory, unlike lists. So the process can access and manipulate them very efficiently. We'll see how it is stored. And this behavior is known as locality of reference in computer science. So this is one of the reasons why it can optimize the CPU architectures, and we can expect very fast performance. So here is the key idea of this this structure. So this NumPy object that we call as ND array object. So ND array is the n-dimensional array. So that's what it is defined as dimensional, called as ND array. So this starts from 0 base index, so that's same as C, because this library was actually written in C++. Every item in an ND array, it takes the same size of block in the memory. So each element of same type, which we can define as D type, and we can customize the elements by changing the D type. So as you can see here, so although it's n-dimensional array can be like 2D, 3D, 4D, 5D, whatever, but it's stored as a sequential block of memory. So like the first, because the multidimensional data can be eventually broken down into small arrays or single arrays, depend from every rows, and they can be stored in a consecutive memory locations. So just by logical additions and subtraction, we can access the head of the different blocks of memory. So that helps to increase the speed of these operations by using ND array. So any item that is extracted from ND array object by slicing is represented by a Python object of one scale array scalar types. And this following diagram shows the idea. So I think it is clear. So now let's move on to the next slide. So here we have a list of some of the commonly used data types. So most of them are, I think you are familiar. So like here is Boolean, int, integer, 8 bits, int p. This is actually an integer indexed for integer used for indexing. So it's more of like a integer pointer. And so the unsigned integer and float, most of you should be familiar with. One new data type is this complex, which are usually not available in C. So they actually help us to perform operations by using complex numbers. So there is default complex, then there is complex 64 and complex 128. So yeah, now we see some of the important functionalities provided by NumPy at a very high level. So some of the mathematical functions here is like some trigonometric operations we can do, like so NP is like abbreviation for NumPy. So we'll show how to use this. Then sine inverse, tan inverse. So all this we can do. Then there is rounding up operations, so which are like NP dot around. Then there are np.floor for a floor of any fractional data. Then ceiling is to find this ceiling. So we can just straight away enter some array, and whole these operations will be done on the whole of the array. Now, commonly used arithmetic operations are also there. So like addition, subtraction, multiply, divide. Also, we have reciprocal, power, and mod operations. They can be done by using Numpy library. Some of the statistical functions that are available is like this a min. So this is gives us the minimum of an array. Then a max gives us the maxima. Then PTP is more of, I think it gives a range of variation. Then percentile, median, then mean, average. These are commonly used statistical functions are provided. And also there are some inbuilt short, search, and counting functions available. So NP short, it gives us, it expects some parameters like A, that is the array. So it can be multidimensional. So which along which axis we want to sort, that is given by this axis. And then kind is the name of the algorithm. So which we can see, I think, yeah. So this one is the more details. So we can actually give input like some particular algorithm here, like quick sort, merge sort, or heap sort. So they have their different time and space complexities. So actually these are space complexities. Sorry, yeah, these are the space complexities. And out of these, merge sort is quite stable, but others are not very stable. But usually for our normal regular size data, we don't see much difference in performance. So there is another interesting function is this Arg Sort. So Arg Sort actually returns the index of the data. So once we have sorted the data, so so Arg Sort gives their the original positions in the array of that main data structure. So similar for argmax, argmin, and so on. So we'll see some of the operations when we go to the Jupyter Notebook segment. So now let's get some brief introduction to Scipy. So Scipy or Scipy it is a scientific computation library. So it uses NumPy underneath. It is also quite fast in operation. So it stands for Scientific Python, and it provides more utility functions for optimization, statistics, and signal processing. So both of these NumPy and Scipy are open source libraries, and we can use them freely. So here is some of the sub packages that cover different aspects of scientific computing. So for example, cp.cluster. So this is mainly used for vector quantization or k-means. So any data which we want to find some clusters, so we can use this module. Then fftpack, we can use it for Fourier transform. Then there is interpolate, which we do to do some interpolation on the data and find some missing data or some intermediate data from a data series. Then the linear algebra routines are there. Some others are like ODR, which is like orthogonal distance regression. cp.signal is for signal processing, and cp.spatial is for handling spatial data structures. And some other important are this ND image. Those of you who work on image processing, for them this will be important. Then there is optimize for optimization. Then cp.sparse, which is for sparse matrices. So sparse matrices are like those type of matrices where most of the elements are zero, only few elements are non-zero. So we can use some specialized algorithms for very fast computations. There are integration routines also, and statistics. So these are the most of the libraries that Scipy provides that we commonly use. So some of the, now I'll go through some examples. So first one is like CP clustering. So for example, it's a use of this k-means. So if you have a data and you define the number of centroids, so capital K is the number of centroids that you need. So if you provide that, so this algorithm can find clusters for any set of unlabeled data. So then from the FFT pack, so if you have the data X, so you can find the Fourier transform by using y equal to FFTX. Similarly, you can find the inverse Fourier transform by using IFFT function. Then there is CP integrate. So this integrate.quad, it expects the input as function. And A and B, these are the lower and upper limits of the function. So these are a numerical integration. So it it gives you the numerical integration value and an error, numerical error in the computation. Similarly, the DBL quad is like the double integration. So we can do double integration also using this one. So function is the function, then A, B are lower and upper bounds, and then G fun and H fun, these are when a 2D function. So these are lower and upper bound functions for the second dimension. So we'll do some examples on this. So then these things will be more clear to you, hopefully. Then there is interpolate. So what kind of interpolation you want to do? So like linear or cubic. So these things can be done by using the operation, the option as kind. Then there is optimize library. So in the optimize module, we can use this type of function like minimize or maximize or least square. So by this, we can specify some method also. So they will help us to solve various unconstrained and constrained optimization problems, or global optimization, or least square minimization. This kind of things are possible. And finally, there is this statistics module, so which has some functions like norm.cdf. So this actually gives us the CDF of the normal function, that is the standard normal Gaussian. So Gaussian function with mean 0 and standard deviation 1. So these are just the points, and based on that, the CDF is built. Same with norm.ppf. So this is actually the probability function. Then the describe is a function that when you give a data set, so it gives you all the major statistical properties of the data set. So some more related functions like gmean, mode, and kurtosis, etc. So these libraries are still growing, and they are already very strong. Okay. So now let's have a brief introduction to the Matplotlib. So Matplotlib is a Python library used for visualization of data. So it's a cross-platform library for making 2D plots from data in arrays. So it can also provide 3D plots, and many other forms of plots are available. So it's mainly used in Python, and it also uses NumPy. So all these three packages like NumPy, Scipy, and Matplotlib, they are very much interrelated. The Matplotlib also provides an object-oriented API that helps in embedding plots in applications using Python GUI toolkits such as PyQt or WX Python or Tinker, etc. So what are the main operations that we can use by using Matplotlib? So it's very much similar to MATLAB. Types of plots are available, like bar H is the horizontal bar plot, then box plot, histograms, 2D histograms, pie, plot is normal plot. Then there is polar plots or scatter diagram, stack plots, stem, step, quiver, etc. For plotting image also, there are few functions like imread, imsave, and imshow. So imread just to read an image. Imsave is you can save a data as an image, and imshow is just shows the data as an image. Then after plotting, you can make some customization with the axis. So there, those features are provided by axis, text, title, xlabel, xlim. So these are something similar that you have already seen in MATLAB if you have used it. So very much similar functionalities of this one. And then there is figure functions, for example, fig test. So this is to add some text within the figure. Then figure, show, save figure, close, etc. So these are, we'll see some of the operations of this function in today's Jupyter session. So yeah. Now some of these Matplotlib features, a bit more details here. So the figure plot.figure, it is actually the top level container for all plot elements. So this is kind of a bigger umbrella of this library. So a figure kind of invokes the main figure. Then there are some functions of under access class. So for more like editing the figure, like figure.add access. So you can add new access by using this function. Then x.legend, so you can add legend in the figure. Then access.plot, it like invokes the main plot with like various lines or markers. Then we can have multiple plots also by using this subplot routine. Then there are add subplot. So this is a very interesting subplot. So here we have multiple subplots, but they will not overwrite each other. Then as a grid of subplots is also possible by using this subplots routine. Then various other plots are also possible, like ax.bar. So this gives us a bar plot, and then pyplot dot histogram. So this is for a histogram plot, so which draws a histogram for any data set X. So I think these are most of the brief introduction to the session. So for this tutorial, we have certain references that these are the main references that we have used. So you can look into them for more details. So now we'll start with our Jupyter lab session. So to see some actual coding. Okay. Okay, so let's first begin with pandas. Okay. So so at first we begin with the series data. So it is, as we can see, it's a one-dimensional data structure which is capable of holding data of any type. So integer, string, float, or any other Python object. And the access levels are called index. So it's basically an index sequential data. So at first, we try to create an empty series. So let's start with a basic example here. So the very first line here is done to import pandas as PD. So we import this library, and then to create a series, we simply write s equal to pd.series, and then we don't need to enter anything. So then just to observe, run this, and the series is created. So it's a blank series now at this point, and it is by default, it's a float 64. So that is the basic type. So now we can create a series from ND array. So as I was talking before, so it is although a NumPy element. So we'll discuss this one later on when we go to NumPy in more detail. So right now we can just consider it as an array of a dimension n. So here this described like this: if a data is an ND array, then index passed must be of same length. So you can pass some index, and if you do not pass any index, so the range of n, so it's like it starts from 0 to a range of length of array -1 will be used. So let's see an example. So here ND is a NumPy object, so we need to use import a NumPy as well. So these two we import. Then we have the data. So we just consider data. So here is a NumPy array, A, B, C, D. So just 4 characters. and then we use series, but here instead of being empty, we just pass this data, and let's see what do we get. So here we did not pass any index. So what we see that A, B, C, D, these are the 4 elements of the array, original array that we had passed, and they are indexed with 0, 1, 2, 3. Okay, sorry, something is in the chat. Okay. All right. So, okay. Yeah. So now here, what happened is we did not pass any index. So by default, it was assigned to the 0 to 1 length minus 1, that is 0 to 3. So this is what we observe. Now let's try another example. So here, now we have taken the same array again, so as you can see with A, B, C, D. But when we are creating the series, so along with the data, we are passing a set of index also. So that is 100, 101, 102, and 103. So now if you print this one, so here you see clearly there is a difference now. So the data remains the same, A, B, C, D, but the index has changed now from instead of 0 to 3, it has become 100, from 100 to 103, whatever we had passed here. So now let's go to the next segment. So we can create a series again from a dictionary. So the dictionary you have seen in your previous session. So let's see how we can create. So again, we just import 2 libraries, Pandas and Numpy. Actually, here Numpy is not needed. So the data we are just entering as a dictionary. So this is just a simple dictionary as you have seen in the previous session. So just pass this data to series. So it's very simple. So and then execute. So here you see. So this data was a float. So 0, 1, and 2. So dictionary keys here, they are used as the index. So this is advantages for a dictionary, because whatever the keys used in the dictionary, they can be used as the index in the series data structure. So now we take a brief look into the next data structure. Okay. Vincent has a question, that is there a link to the files used in the first sessions? Yeah, we'll be sharing the files. I think Karishma is going to share that. So yeah.
I'll answer that. Thank you.
Okay. So now again, let's start with the same exercise. So we'll first create an empty data frame. So let's do a quick example. So we just import pandas as PD, and we can define a DF, which is a data frame, equivalent for data frame, and it's a blank one. So let's see what we get. So this is an empty data frame. So here it's a 2D data. So there are columns. So both are empty, and index are also empty. So now we can create a data from a single list or list of lists. So let's see. So data here, now we are just creating it as a list. And from there, we are creating a data frame. So this is a very simple example, and let's run it. Okay. So the data here, we had 1, 2, 3, 4, 5. So if you can see, So data is 1, 2, 3, 4, 5. And in the left side, these 0, 1, 2, 3, 4, these are the indexes corresponding to the rows, and the top 0 is like the index for the column, because it's a 2D data, so we have two sets of indexes. So now we take a different form of list. So data here now, for example, is a name Alex, and followed by we have an integer value. So these are indicates, for example, age. So now we can introduce our manual indexes. So one columns is name, and sorry, first one is the name and second one is age. So if we print this, now here we see the left side, the row number remains in this order 0, 1, 2, but the column indexes have now changed. So they are become now name and age. So we can customize this way this data structure very easily. So now let's take another example. So the previous one, so by default, this data was stored as integer. Now we can change the data type. So as we have mentioned about D type, so instead of integer, if we put float, so this data will be changed to float. So what we see here now, so the name remains same, Alex, Bob, and Clark, but the age now has become in floating point. So, okay. Now let's make use of data frames from other data structures. So and a second data structure that you use is dictionary. So you have seen a dictionary. So and we'll try to create a data frame from a dictionary. So for example, here we have the 2D dictionary. So that is, I mean, that's dictionary with like the first key is the name, and for there we have 4 entries, and age for the second key, where we have another 4 entries. So now we just pass on this data to this data frame function, and it will create a data frame. So let's see how it looks. Yeah. So now you can see that the name, under name, automatically these names, 4 names have come, and under age, the corresponding ages are visible. So, okay. Now we can again change some of the index. So, so this index now, this will be actually row wise. So if we run it, so here we see the row wise index, it has changed. So earlier it was just 0, 1, 2, 3. So now it has become rank 1, rank 2, rank 3, and rank 4. So in this way, you can customize your both labels or indexes to access the data in a data frame. So now we'll see that how we can select some columns from a data frame by using this library. Okay. So here, the first one we see it's let's say D equal to 1. It's again a dictionary, and we are passing some index also, and for basically it's actually a series. We are creating it in this way. So pd.series and followed by some index. So observe that the very first one, it has just 3 entries, A, B, C, and the second column, it has 4 entries, that is A, B, C, D. So when we try to data frame, something interesting will happen actually. So okay, so let's first print. I think it is not visible. So first, let me print df. So actually, Yeah. So the first one had 3 entries. So that is 1, 2, 3. So the 1 came here, but the second one had 4 entries, 1, 2, 3, 4. So because no entry was available in the first column, so it was populated as not a number. Now you can select just the first one. So let's just print now df1. So 1 is the index for the column 1. So we can just simply pass it like this way. So df and within third brackets 1. So it will just give you the first column of this data frame. Okay.
So, sorry to interrupt. I think there is a question in the chat associated with the same problem. I thought I'll just let you know before you move to the next one.
Mm-hmm. Oh yeah. Okay. So yeah, this one I think, yeah, it's interesting. It should not happen actually. For one D type, actually, I think it is taking as by default the data type is float, so it is showing us D type as float. But second one, yeah, that's interesting. Okay. Maybe it is because I think while the second row, second column is being added, it's some change. Okay, let me just see if I just have 4 in the first one also. Oh, sorry. I think. Yeah, I think in the second one, while this is overwriting this one, it is create a problem. So normally, yeah, it should not be, because it's, I think the not a number is treated as a float. So that's why it is changing the default data type of column 1 into float. So normally, yeah, they are both integers. So I think this answers your question.
Yeah, thank you.
Okay, so okay, let's move on to the next part. Okay, so now it's like the column addition. So okay, so again here we have 2 columns. So one is a series of like A, B, C, and then second one is 2 is 1, 2, 3, 4. So we get creating a data frame from this dictionary of the series. From there, now we can first add. So first we are just adding one column. So if I just run this one. So what we see here, so we have already seen the data frame of 2 columns. Now we are just adding. So it's simply by using the syntax. So df and then third bracket 3. So this one only will help you to add a new column, and then you just put the data as a simple one-dimensional series, and it will just add. So whenever I think, yeah, whenever there is this not a number is coming, so it is actually a float. So it is typecasting the whole column. And then we can add just two of these array, two of these columns. So that is 1 and 3, and we can create another new entry in the data frame. So that is df4. So this gives us the fourth column. So if you see, these are just simple additions of 1 and 3. So that is addition. So now we can delete also some of the columns. So let's see. So here we have created first as this one. So this is our data frame. The first data, which is like again three consecutive series in a dictionary, and from there we are creating our main data frame, and then we can use this del function. So simple del, and which one we want to delete is df1. So the first one we want to delete. So if we run this one, so here we can see that our first data frame was this. So we had 1, 2, 3 columns, and we have deleted the 1. So that is first one is gone. So now we are left out with 2 and 3. So there is another function also, which is known as pop. So it is its syntax is slightly different. So you can use the df.pop and just enter index of that particular column. So then it will delete the second column. So we are finally left out with just the third column. Okay. So now let's move on to the next segment. So it is like some row selection, addition, and deletion. So previously we have seen operations with rows. Now let's see with rows, operations with rows. So again, a similar data frame is created. Now to access a particular row, we need to use this df.location, so or LOC command. So that gives us this one. So okay, let me just print df also here first, so that it's easier to see what happened. So first one is df, as you have seen. It has 2 entries, 1, 2, 3, and then second column has 1, 2, 3, 4. Now we have entered B, so that means we have got two separate entries from first column and second column. So they are just given like this: 1, 2, and here also 2. So here the data type is given as float 64, although the initial data was entered as integer, but I think again it's one of the data is data point is float, so it is typecasting the other one also. So yeah, we need to be a little careful, I think, when we are making these sort of operations. So now let's try the integers allocation. So for that, we have another function which is known as iloc. So here we can just pass the integer value, that is, for example, 2. So first, before we do the operation, let's print df. So this was the initial entry of df, and we are using iloc 2. So that means the second row. The second entry. So here actually index starts from 0. So that is 0, 1, 2. So which is C. So that is we are having 3. And its name was C, and data type is float. Now we can slice the rows also by using the colon operator. I think some. So again, we have a similar data entry. Okay. Now, so we are slicing from 2 to 4. So let's see what we get. So that means we just have here, it starts from C, so row with index C, that is 3 and 4, just 2. here we have. So because it does not take the last one, you have seen the property of slice in previous session. So it's just taking the last two entries here. So we can also do addition the rows. So if you want to add a new row, so you can just use this append function. So we have df, so that is the default one, and then we can add some more ones. So let's print before we do the operation, we print, and then after also. So initially, before we did the append function, it was just this, the row-wise indexes were 0 and 1 and column-wise AB, and the data was 1, 2, 3, 4. Now we have added two rows, 5, 6, 7, 8. So you see they have added, but observe that the indices are repeated here because we did not provide separate indices. So the row-wise indices were used just the way they were. So there is a repetition of row-wise indices. Now we want to delete some rows. So for that also we have functions. So the way we added, now we can drop also. Let's do a print of df. Okay, so when we added here, so you see 0, 1, 0, 1 were added, but now when you are trying to drop with level 0, so both these rows with level 0 will be dropped. So we are only left out with rest of the entries with level 1. Okay, so now let's go to some more functionalities of Pandas. So here we have some, we can use some random number generation. So this is a very straightforward. So this is just 10 entries and random. So these random is just Gaussian normal distributions and just 10 numbers within 0 to 1. This is some of the axes, what are the axes of this? So this is created as a series. So this gives you the details. So it starts from 0 and stops and 1, and steps are equal to 1. So if you change them, so they will be different. Now we can check that whether some data array or some data, whatever we enter, whether it is empty or not. So again, we are creating a series, and then we are just checking whether it is empty or not. So if you just do s.empty, so that will give you this Boolean output. So it simply gives you false. Then we can also check the dimension of the data. So here we had created, for example, a series of 4 random numbers. So what is the dimension? We see it just tells you the dimension as 1. Then we can check the size of a series. So here again, we are creating a series of 4 entries, and then what is the size? So s.size. So once the data is created, so you can just put s.size. So that will tell you the size of the object as 4. Then what are the values? So the value of actual data. So these will simply give you the values. So the series that you created here, it just returned in a different format, but it's the same numbers only that were there. And these are very interesting features of Pandas. So these are like heads and tails. So if you have a big data, but you don't want to see the whole data at one go, so you just want to see some of the initial entries, so you can use this head function. So for example, here I have created a series of random numbers, 10 random numbers, but I want to just see the first 2 rows. So it gives us like this. So the original data series was like this, and it just shows us the initial two entries. So you can add any number. So by default, head just gives you five entries. So it can be a 2D, 3D, or any order of data. Head does the same function, same operation. And tail gives you the last few ones, I think last two. So if, for example, if I just remove that one, so by default, it will give you, I think, last two. Sorry, it is giving us, oh, the last 10, okay. Now we just customize with 3, so we get just the last 3. So okay, so that's more of about pandas. So we'll have more details on pandas on next session. So now let's quickly go to our next segment, which is NumPy. So first we begin with ND array object. So okay. All right. So first one, it's a NumPy array. We can just create a simple one-dimensional array and see what it does. Yeah, so it's a very simple ND array with 5 elements, and its type is a NumPy.nd array. Now this is an array of integers, so we can create an array of data type complex. So as we had mentioned earlier, so you can simply enter 1, 2, 3, but you can change the data type to complex. And here you see it's a complex entry here. So 1 plus 0 dot j. So you can directly use some complex entries also in here. So maybe let's say 2. So here if you see, so if I entered like 1 plus 2j, so the entry now is here. So this is you can do. Now we can use a tuple to create an NumPy array. So tuple you have seen in the previous workshop session. So just straight away it can create an array from a tuple. Now the dimension in arrays. So we start with the 0 dimension array. So it's just like a number. So just a simple integer or float, whatever. So just a single number, which is a 0 D array. Just this. So 1D arrays you have seen. Now let's okay. We can create a 2D array. So here the syntax you need to observe a bit carefully. So the very first one is 1 to 1, 2, 3. This is like one dimensional array. Basically, these are lists that are will be converted into arrays, and then another list 4, 5, 6. So that is being converted into the 2D array. So now here you see it's created a NumPy array like this way. It's a 2D array. Now the next example is a 3D array. So here also is a similar way. You can just enter, but as we are going to enter a 3D array, so it's like 2 of 2D arrays. So at the extreme left, you need to have 3 consecutive third brackets, and they are entering again at the extreme right. But in between, the organization is in a certain way, so that you can create it like this. So now you see, so these are 2D arrays. So this way we have the third dimension. So we can also check the minimum dimensions. So here, using this parameter, we can create an array. So we are just entering simple elements 1, 2, 3, 4, 5, and we are entering this parameter ND min. So if we just use this one, so here actually we are creating a 2D array, but actually it looks like an 1D array. So there are many ways of creating these arrays. So you can do it as per your wish and the way your data structures need to be handled. Now we can check the dimensions also. So for example, this is okay. We have a set of arrays here, one A, B, C, D. We have created different types of arrays. Some of the examples that you have already seen, and we want to check the dimension. So just put a.ndim, so that will return the dimension, and we are just printing them. So let's see. So yeah, we can see that ndim just returns the dimension of those arrays. So that is a was just a number, so 0, then simple array 1D, then 2D, then 3D. So we can even go for higher dimension also. For example, you just can create an array of 5 dimensions. So here we have already seen the use of ndmin a parameter. So just simply enter 1, 2, 3, 4, and we can print the array and we will check the dimension. So let's see how it does. So here we have just these 4 elements, but you see there are like 5, 3, this third bracket. So that means it is actually a 5 dimensional array, and the dot ending also giving us the same. So these are as per our wish. We can customize. Okay. So now let's look into the NumPy array indexing. Okay. So so how can we access some of the array elements? All right. So the NumPy array creation is this. Now this is like a simple way of accessing an element, just the way you do in C or in MATLAB. Somewhat similar. So ARR 0, that enters the first one. So if you say put 2, you will get 3, something like that. So this is very easy. Yeah. So I think it goes on like this. So you can also perform addition also, just ARR 2 plus ARR 3. So they will give us ARR 2, 3, that is 3 and 4. So their sum is 7. So that's what we get. So similar way, we can also access 2D arrays. So let's see the first example. So this is a 2D array is created, and to access it, just put the locations. That is, first one is the number of the row number, and second one is the column number. So yeah, it's a so array is 0, and okay, let me just print ARR so that you can see clearly. Yeah. So this means ARR 01 means the first row and the second column. So that is 2. So index starts from 0 both ways. So this is what we get. So if we just put say 3, and this one we put 1, we get 9. So you can see that second one and 3 means here. So 0, 1, 2, 3. So yeah, similar. I think these are similar examples. Second option 10, and then we can have third element of the second array also. So this one. So this one is actually a 3D array. So as you can see, there are 3 third brackets. So like the more dimensions you increase, so you just need to go on increasing the numbers so that you can access it. And the interesting feature is also you can do negative indexing. So that is, you can access the array from the end. So that is also somewhat something you have seen. So here ARR 1 and ARR -1. So that means it is coming from the so it's like a last element from the second dimension. So that gives us the number 10. So this one here. Now we can see the operation of ND array shape. So this one, it returns a tuple consisting of array dimensions. So this can also be used to resize the array. So first we have a simple NumPy array, and let's see what we get by using a.shape. So it gives us 2, 3. So that means we have 2 rows and 2 columns. And 3 columns. So now a.shape, if we had 2 and 3, so we can just change it to 3 and 2. So just if we reverse it, now we will get something different. So you see they have just reversed here. So this way we can change the structure or shape of an array. So there is another function also which is known as reshape. So that function also we can use. So here we had 2, 3, and we can just change it by using 3, 2. So this also does the same thing. So these are 2 ways of doing the similar operation. Okay. Let me see if I can increase. Yeah. Hopefully, I think. Okay. All right. Okay. So okay. Now we can see the n dimensions. So all right. That part is done. So now let's look into another function. So this function is okay. Yeah, so a range is a function. So basically this creates, so if you can enter any integer, and it will give you a sequence of numbers starting from 0. So if you have given 24, so what we get here is an array of numbers starting from 0 up to that number minus 1, so that is 23. So an array of evenly spaced numbers that we get. So now by using this, you can simply create a reshape into any form or any form of higher dimension of data structure or array. So here we are using 2, 4, and 3. So okay. So here you see we had total 24 entries. So the first 12 is first created 2D matrix of 2 by 4. 4 by 3, and such 2 matrices are created. So actually the 4 here number represents to the number of arrays, and 3 indicates number of columns, and 2 indicates the number of such matrices will be created to have a 3D array. Okay, so now let's go to another function which is known as item size. So numpy.item size. So this will return the size of element in bytes. So here, so let's have simple data 1, 2, 3, 4, 5, and put the data type as np.int8. So now if we do a int item size, so we get size of 1. Size of x as 1. Now again, we can change the data type, just keep the same array, but change the data type to float 32, and now do the same operation. So you see it is now changed to 4. So depending on the size or the data type, the size of the stored data will vary. Okay. Now, some of the array creation routines. So these are something similar exercise that we have already done. So let's start with an empty array. So just use this empty. So first is a dimension, and then d type is the what is the data type, integer, and then you can print. So actually these 1, 2, 3, 4, 5, 6, they look very nice, but these are actually not the values. These are some garbage values, but they are actually because of this compiler, I think initializes it to these nice values, but these are not the values that you entered. So these are actually an empty array. So you can use them for any later on you can override them with your required values. So you can also initialize with zeros. So just do numpy dot zeros, say 2 by 2, and what is the data type? So then we can enter. So here you see it's actually an array of tuples. So these are like this. You can also fill it with ones. So this is again another one. If you see, it's a 2D 2 by 2 matrix or 2 by 2 array. ND array is created with all elements 1. So this is another job. So now we have a special type of function, so which is array from an existing data. So if you have an array, so from there you can create some ND array. So initially, say here we had a list 1, 2, 3, and from there we can create an array. So here from list to ND array we created by using this AS array function. Now again we can change the data type to float. So let's see what happens. So yeah, it's from integer it became a floating point array. The next one from a tuple also you can convert an array. So these are some of the useful functions that you need when you are working in practice. So these are of 2 different dimensions. So let's see how things go here. So yeah, so here you see it's an array created, but they are kept as tuples of different sizes. So this is very flexible in doing such operations. So you can do it like this. Now there is this numpy arrange. Okay, so this one again will format the data. So this one you have seen, it gives us the evenly spaced numbers. We can also have them float instead of integers. We can have floats, and finally you can just like we had just evenly spaced, so on. So you can just give us starting number, ending number, and also what is their intervals. So here we have intervals of 2. I think then it will give you just these 5 numbers from 10 to 12, 14, 16, and 18. So you can customize also. So next we have the lin space. So it actually mainly linear spacing related operation. So here again, lin space will give you a linear space of this size. So you see from 10 to 20, and they are increasing in this order. So from 10 to 12.5, 15, 17.5, and 20. Now, if you set the endpoint to false, then the endpoint will not be there. So the 20 is discarded. So it just starts from 10, 12, 14, 16, and 18. So basically linear space means it actually divides. So here like 10 to 20 is divided into 5 numbers. So this is how we get like 2.5. It's an total interval of 10. So it is divided into 5 intervals. So that's how you get these numbers. And also here, the return step size, read step. So this is actually true. So here it's actually 0.25. So here you see what you get. So 1, 2, and 5. So we go up from 1 to 2, and in the steps of 5. So this is how we go. Like 0.25 is the default one. So you can customize this also. So from linear space also we can use log space. So by default, its default base is 10. So I mean the spacing happens in the logarithmic scale. So this is somewhat similar. So from 1 to 2, so that means from 10 to actually 10 to the power 2, that is 100. So this is growth in logarithmic scale. And we can also change the base from 10 to 2, something like that. So then again, you see that growth is happening in the power of 2. So then indexing and slicing, I think this part is very much similar. So I'll just keep this one for now because of shortage of time. You can go through them later. So some of the interesting functions that we have in NumPy is like trigonometric functions. So here, so we can have like some array, and we can change it. The value of pi is provided by different libraries. So pi is there in NumPy. It's just a simple conversion, like from if your angles are in degrees, so we just convert it to radians, and then we can get the values here. So sine, then this is a similar way of finding cosine. So you can just enter an array and you can get the values in a direct way. Sine, cos, tan, these are very common. Now this is functions for rounding. So here, if you see, the original values are, okay, there's some question. Okay. Okay, so after so these are the fractions, some of the floating point values. So in fractions, so we do first we print the original one, and then we do some rounding, and we can choose the number of decimals also. So for example, here is just 1. So you see, okay. So if you just do rounding, so then no decimal points are converted. So straight away, they are just 1, 6, 1, 2, 3, 1, and 26. But if you consider one decimal point, so the one decimal place is considered. So you can change them to something else also. Then there is the another function that I was talking about earlier. So it's floor. So that is the lower bound of the numbers. So here we have like minus 1.7 goes to minus 2, 1.5 is 1, minus 0.2 to minus 1. So like this. And this is the ceiling function. So that is upper bound of the fractions. So the whole array you can enter and you can get it. So some of the arithmetic operations also, again, very commonly done operations, like say first one is the addition. So two arrays we have and so first one we had A, and then we created another one which is B. It's just an array of 10, 10, 10, and first one is a range of 9, so that is 0 to 8. So if we just see, so the first array is just this, and the second array, so we just add. So this value A plus B, so B gets added to all the elements in the, I mean, basically it's a row-wise addition. So that's what is happening here. Then we can also subtract. All right. So here I think A minus B. So that's why all these things are happening, coming with negative sign. We can do multiplication also. So all the elements, they are multiplied row wise. This is element wise multiplication, and then there is a division. Now we come to the reciprocal function. So reciprocal is actually inverse. So here we see it's a floating point 1. So 0.25, 1.33, 1, 0, and 100. So if we do a reciprocal here directly, so here we see a warning. So why that is coming here? Because there is a 0. So 0 is creating this problem here. So it is being written as infinity, but yeah, rest are all taken care of. Now, one interesting thing is, so for example, here we have just one entry that is just 100. And if we do a reciprocal of this, here we see it is coming as 0. So observe that here in the previous one, when we had 100, you did reciprocal, you found 0.01 because actually it was in a floating point. So that's why we got this one. But here it is treated as an integer and its reciprocal is treated as 0. So for any number greater than 1, if you have it as an integer, so if you do a reciprocal, then it will be it will give you as it will return you value 0. That's why you should be careful while doing this kind of operations. Then there is this numpy.power. So you can simply just raise an array to some power, for example here a, and you just raising it to power 2. So all the elements are squared. So it's very straightforward. And you can use another array also. So you can just use the second array b, and you can take a and b. So then each element of a is taken to power, like the first one was 10. So 10 to the power 1 is 10. Then second one is 100. So 100 to the power 2 is 10 to the power 4. And then third one is 1000. 1000 to the power 3. So that means 10 to the power 9. Then mod is the remainder function. You probably know its use. So here again, we have two arrays, a and b. So when we do mod b, anp.mod and remainder. So these two functions are very closely related functions. So you can just directly use them. So mod function just give you the modulus, and then the remainder gives you the remainders in these cases. Then some of the statistical functions are also there, which are like mean, max, something like that. So these are very again, like you just create the a array and then you do a min of this, and one is like the axis through which direction you want to search actually. So this one gives you applying a min function. So one means basically column wise. So that means first one is 375, minimum is 3. The second one is again 843, minimum is 3, so you get 3. Third one 249, minimum is 2, so you get 2. So it goes like this. Yeah. Again, 0 means column, row wise. So they give you values like this, because here you see 283 is minimum is 2, then 744 minimum is 4, and then here 539 minimum is 3. So that's how it is. All right. So again, this is max and similar operation for max. So these are the similar way of working. So I think it's very clear to you. Then rest is again mean, average, and these are some of the statistical operations. Average. So these are things again I am going to skip for now. You can go through later on, and most of the things I think you know or have understood how to use the syntax. So let's go through quickly some of the sorting algorithms. So here is, for example, it's a sorting. So we have a 2D array, and you can use, for example, I'm using here quick sort. You can change anything else also. So sort function. So here, what is happening? So first one is 3, 7. So this is sorted column wise. So first one is just sorted. So it is nothing is changing. Second one is 9 and 1. So 1 was smaller. So it is just changed like that. So you can put a direction here, axis equal to 0. So now it is sorted row wise. So 3, 9 again it remains same, and column wise it just changes. So this is again a little complicated array, so which has like a lot of entries, names and ages like that, and we want to sort by order name. So let's see the array. So that it is like a arrays of this tuple. So name and followed by age, and you are sorting by name. So it's just alphabetical sorting is happening here. So you can also use Arg Sort. So Arg Sort, yeah, just gives you the index-wise sorting. I mean, after indexes of the sorting. So this is what the Arg Sort gives you. So these are just the indices, as you can see. So reconstructing now you can use the indices to reconstruct the original one again. So 1, 2, 3. So you can see that now they are sorted. So it's basically using the same algorithm, and yeah, while loop. Both way, I mean, whichever way you feel like you can reconstruct. Okay, so NumPy non-zero, basically it returns that whether there are non-zero elements. So this is, for example, an array where there are 0 and non-zero elements. So yeah, so it gives us the locations of the non-zero, I think. Yeah. So 0, 0, 1, 1, and 2, 2, and these are, yeah. So, and finally, there is this where function. So where is like if you want to find a particular element, so it will just give you its coordinates. So for example, we indices of elements were greater than equal to greater than 3. Arrange we are using. So here we have, for example, an array with, and we want to find indices with greater than 3. So it will just return you the positions of that. And last one, we can, to get the satisfy the conditions, just to print out. Yep. All right. So this is the one, I think, on NumPy. So now let's quickly go through Scipy. Okay, so I'll go through. Okay, so this part will have certain pre-processing, and this is a very, we'll start with a very interesting sample. So, so this is a commonly used clustering or machine. It's considered as a machine learning technique also. So we have some data, and we don't have any defined labels on the data. So we try to find some clusters within that unlabeled data. So how do we do that? We'll show some step-by-step process of this one. So a couple of important libraries that we need to import here. So first two, because as we have seen that Scipy is largely relies on NumPy. So we have to import these two special libraries, vstack and array, and also this random library. And from Scipy we import this cluster.vq, that is vector quantization, and these three things we need to import. So let's start with that. All right. Now, so once we have done that, now we first need to create a data set, so through which we operate. So this, you can have a real data, but for time being, okay. Okay. Okay, so let's first quickly start with this one. So we stack. It is just arbitrary data. And so now we have the data, but we want to normalize the data because different data, if they are of different scales, so they might create problems when in with features. So that's why we call this an whitening of the data. So basically, this is just normalization. So we divide the data by the max. So now it is very simple. So we just want to create a cluster of with three centroids with the data. So k-means is the function. So this one we have already seen in the slides. So and this, it will return us the centroids. So here we see these are the because we had a 3D data. So our centroids are also in the 3 dimension. So these are the coordinates. And based on that, now we just apply this VQ. So and data and centroids. If we just apply this, they will give us the labels. I mean, the number of clusters, the cluster number associated with each data. So this one you can like cross check. We can cross check later on by using suitable plots and all. So those things we'll see later. So now let's quickly go through some of the constants. CP actually provides us a huge list of constants. For example, a pi, the commonly used constant, and there are several units also. For example, this is the main directory. It's actually have everything like gas constant, light year, all sorts of useful things, and it also has all the SI prefixes. So I'll just quickly go through these. These are very straightforward. I think you are just familiar with. So these are the values, and it supports all this range. So these were the memory size. Then this is the mass. So that is from gram, ounce, pound, etc. Angles also it from degrees and arc minute, arc seconds. All these details are provided. And this is the time. So minute, hour, delay, Julian year, and lengths also. So inch, float, inch, foot, mile, from the very big to the very small. So everything is covered in this library. So now we take a look into some of the optimizations, optimization library. So here, for example, we want to find a root of the equation, so x plus cos x. So we can numerically find it. So here we can define this function like this, return x plus cos x, and my root. So it's just this root function. So root will do the job for you. So we just put the equation here, and you just need to import these two cp.optimize library and import cos from the math library, math module. Yeah. So then this will just solve the equation straight away. So my root.x will actually give you the value of x, but my root has many other information. So if you want to just see that, so here we have like the solution, whether converged or diverged, then what is the final values, and I think this one is okay. Okay, so yeah, there are some other functions also. So I think, yeah, today we are almost close to this session. I think we have just 30 minutes left. So we'll cover rest of the materials maybe next session. So now I think I can hand over the session to Kishore. So we'll do some HackerRank coding practice.
Hi, everyone. I guess it was a lot of information for 1.5 hours. So I hope you guys got the gist of it. So basically, the point of this session, we did add more information so that we can get started on some real life sort of data analytic application, data analytics problems from coming sessions. So that is why it might have looked like there was little more content than last week. Last week we went intentionally slow so that you understand the Python basics. So to just give an overview of what was taught today. So it was just like one of the advantages of, that's what I mentioned in the last week as well. So one of the advantages of using Python is that it has got a very vibrant open source community where you can sort of develop your own libraries. There are different libraries available for different purposes. And those libraries in turn make your life easier when you are doing some sort of data analysis, because each type of data will have its own requirements. So based on some sort of classification, say for example, dimensions of the data, as in whether it is a one-dimensional time series data or say a multi-dimensional image data. So based on those categorizations, you can have different libraries. So that was what today's session was about. Some general libraries that will give you a comprehensive idea. So for example, you learned about, of the four mentioned, mainly important ones are Numpy and Pandas. Numpy basically helps you create efficient arrays. Now you have basic arrays in Pythons, especially Python lists, but as Sourav mentioned, there are whole lot of other functionalities with Numpy that you can do, be it sorting, be it getting the minimum arguments, minimum values, and things like that, even polynomial functionalities. And to add to that, Numpy is significantly faster because of their organizations in the memory. So that is one library. Then you have the Pandas library, which is actually, if at all you had to pick one library that is the most important, it has to be next is Pandas, especially for data analytics purposes. At its core, you have something like a data frame that you use to represent time series data. So mainly for a time series data analysis, Pandas are extremely useful, and they have got a lot of functionalities that you can use for data pre-processing and things like that. I hope today you got a very basic idea of how to construct a Pandas data frame from a dictionary and how to convert back. So in the next session, we will build on that and I'll explain like how can you read from a Excel file. So if you might have a time series data in an Excel or a CSV file, so which would be organized according to time instance, like it might be from a biomedical domain like a ECG curve or any other accelerometer data, any other time series data. So how you can read from a CSV file into a Pandas data frame and then do basic processing and analysis. So those two are the most important libraries, I would say. If you have any questions, feel free to ask us. And because of the more content on this, we do not have much advanced problems on HackerRank. We only have few basic problems, again, concentrating on Numpy mainly, just so that you get a better and clear understanding of it before we move forward. So before we jump to that, if you have any questions, please feel free to ask. It might be from today's session or it might be from last week's session as well. Or also if you guys have any specific requirements for any types of like particular libraries that you might need for your applications in your some courses or things like that, you could think about that. We can try to include some concepts on those, or even we can include problems in the coming session.
There is a question in the chat.
Yeah.
So the question is Python generally suited for symbolic computation?
So what exactly?
Generally, is Python suited for symbolic computation?
I got that. I'm just trying to understand what exactly.
So,
symbolic
I'm unmute. So
could you unmute the mic, please? Yeah.
Yeah. And would you please ask a bit detail about it?
Thank you. Kishore, sometimes you see computer algebra systems.
Yeah.
Can computer algebra be done in Python?
As in sort of like solving a polynomial equation or a
correct
matrix inverse and things like that.
Yeah,
of course you can do that, and I think that is one of the uses of Scipy library. It has got quite a bit of functionalities where you have got like a lin ALG module within that, which you can use to solve a simultaneous equation, or you can even use that to determine matrix determinants and things like that. And as Sourav was discussing, there are a lot of optimization functions which you can use if you are like looking to optimize a particular objective, like given a f of x, find a x that minimizes this f of x. So you can try to find local optima, and then you have a whole lot of advanced machine learning and what is known as like deep learning nowadays, especially. All those things obviously rely heavily on linear algebra and optimization. So yeah, most of the things, yeah, it's very much suited for that.
Thank you.
I hope I answered your question.
Yes, indeed. Thank you.
Probably you could get started with hacker rank.
Yeah, we're already 6:40 anyway. So for example, if you want to look at, say, of these questions, let's look at how we just to recap. So let's look at this. Before this, let me share the link. So I'm pinging the link here in the chat. So please open the link so that you can access the contest. So these are very, very simple and easy questions. Say for example, let's start say with this. So this question basically discusses about the shape tool or the shape function in Numpy library. So where the shape, it gives a tuple of array dimensions, and it can be used to change the dimensions of array. So for example, here you can see it gives a tuple of array dimensions. So you may recall a tuple from our previous session. So here, for example, you can see you have numpy.array of this array, so which is a list of lists, and this is sort of how you would use a constructor numpy.array to declare a numpy array. So you have this numpy array, and if you do my2d array dot shape, then that would give you a tuple, which is this, which has got 2 dimensions. So where you have got 3 representing the number of rows, or one dimension or along 3 rows, and then you have got 2, which is the number of columns. Then you can also sort of use that to change array dimensions. For example, you have a numpy array, which is 1-dimensional flat array, 1, 2, 3, 4, 5, 6. Then you can write change array dot shape. So that would become and assign it 3, 2. Then that would change the shape of this array. So that's one important function. So you have got the shape tool associated with numpy array. using which you can access the shape and dimensions of the NumPy. Similarly, you have got Reshape Tool, which, as the name suggests, reshapes the NumPy array. So if you want to, so it gives a new shape to an array without changing its data. So it creates a new array. So you can see here the difference is that here if you read the change array dot shape here, so this modified the original array itself. So if you do not want to modify the original array, and if you instead want to assign and create a new array, then you use something known as reshape. So which would be this. The reshape tool gives a new shape to an array without changing its data. So for example, you have the same NumPy array, which from 1 to 6. So NumPy dot reshape this to 3, 2. So that would give you 3 rows, 2 columns. So shape and reshape. So that is what this program asks you to do. You are given a space separated list of 9 integers. Your task is to convert this list into a 3 by 3 NumPy array. So you have this input. You just have to convert it to this. So which is, so you first you have from a space separated list of integers, you have to first construct a list. From a list, you have to construct a NumPy array. From a NumPy array, you have to construct a NumPy array of required shape. It's pretty straightforward. Maybe I'll just give a couple of minutes if you have any doubts, or if you or you can do and submit it before I share the solution. So this is pretty much what it looks like. So let's import NumPy is given anyway. So here, so as we did in the earlier session as well, here nothing was given. So one of the ways to read inputs from keyboards in Python is input. So just like how you would use raw input here in HackerRank syntax. So this would give you the input from keyboard. So in this case, whatever input the HackerRank when you run a code on this, so whatever input you get from the HackerRank interactive session, so you get that input here. So now you always, when you are writing it here, so you should see you are given a space separated list of 9 integers. So you have this raw input, which is split into this temp array. So this will have 9, this is separated by space, and you have got 9 integers. So for I, so you need to construct a loop for I in X range of 9. So which means you have got 9 elements. So it will run from 0 to 8. So temp add this one of I. So this, once you do the raw input dot split, because you have got a space separate like this, here you can see here. So you will have 9 values. So you are just reading those 9 values in a loop. And using the append function of the list, you are creating an empty list here. Now you can create this empty list like this using empty square brackets, or like this, which would also create a list, which is using a constructor to create a blank list. Or you can just use this square bracket. So that is an empty list. Now that's very useful sometimes because here you are it asks you 9 space separate integers, but in some cases you may not know what is the size or how many values you are going to read. So in that case, it's better to have a empty list and then just go on appending. So you just go on appending here. So you will end up with a list that consists of these 9 values. Once you have that, then you have to convert that into a NumPy array. So you have import NumPy. So NumPy dot array of this ARR array will give you the NumPy array. So once you have the NumPy array, then all you have to do is just reshape NumPy dot reshape of array to 3 by 3. So that should give you the desired output, which is this. So you just, this is the input given and this is the output expected. It's a fairly just concentrating on the shape and reshape aspects of NumPy library. So let's quickly look at one more question. So polynomials. So for example, NumPy has got this poly tool, like how I said. So the shape tool is there, shape and reshape tool is there. So similar to that, you have got poly tool, which is POLY, poly tool. So which is for polynomials. So poly tool returns the coefficients of a polynomial with the given sequence of roots. So you would have a, say, a second order polynomial or a third order polynomial, right? So NumPy.poly, it would give you from the roots, NumPy.poly of roots. If you do this, it will give you the output this. Here, these values represents the coefficients of the polynomial. So like say it would be something like a x cubed minus 11x squared plus 9x. Okay, x power 4. So it starts at 4, 3, 2, 1, 0. So it constructs a polynomial from the given roots. Other way around, roots. Oh, sorry, not yet. Oh, I clicked on roots. The roots return the roots of a polynomial with the given coefficients. So it's exactly opposite. So if you do NumPy dot roots and give the coefficients of the polynomial, then you will end up with roots. So then there is polyint tool, which returns antiderivative or indefinite integral. So without any integral limits of a polynomial. Then you have got poly DER, which is derivative thing. So for example, you can see here, x cube would be 3x squared. So you'll end up with 3 here. And then x squared would be 2x and x would be 1 and the constant would be 0. So this is for derivative. Then you have got polyval, which what it does is given a polynomial, say for example, you have this polynomial, which is x cube minus 2x squared plus 0x plus 2. So basically you have x cube minus 2x squared plus 2. Evaluate this polynomial at 4. So it is what polyval does. And then this is another important one, which you might say in some sort of very preliminary data analysis sort of things. If you want to fit a polynomial of a specified order to a set of data, so using least squares approach. So I hope you know about least square approach. So where you have a set of data points. For example, you would have, say, 5 data points, and you want to sort of fit a polynomial curve that passes through those data points. Then you want to fit a curve such that the data that you have, actual data and the fit data, so that the error between them squared should be as minimum as possible. So that is known as polynomial. So bit more generic than that. It's mostly known as curve fitting. So where you want to fix a curve to a particular set of points, like you want to set a Gaussian curve, or you might have, like in today's, especially in this COVID time, so you would have every day come across a exponential distribution. So where the cases are decreasing exponentially, increasing exponentially. So that's one of the that's where, when you have the data, speaking in a very simplistic manner, that's one of the very relevant and practical applications where you can see you have the data, and to those cases and other things you fit a exponential curve. And when you're fitting a curve, you would have some criteria like minimize this error, minimize that error. So like that, you hear this is it fits a polynomial of a specified order. So whether it is quadratic or a cubical or even higher order, using a least square approach. So this question asks the same thing. It's very simple. So it's more to understand these things. So you are given the coefficients of a polynomial P. The task is to find the value of P at point X. So as I said, the first line contains space separated value of the coefficients in P. So you have got the polynomial coefficients which are separated by space. And second line contains value of X. So for example, here you can see 1.1, 2, and 3. And this is the value of X. So plugging that in. So here you can see, for example, this is 1.1 x squared plus 2x plus 3. So if you plug in x0 here, this would obviously be 0. This would be 0. You would be left with just the constant value, which is 3. So this is a one-line program. This is just to sort of give an example. So for example, here, if you want to use this, or if you want to actually read from what they have given, you would want to write this way. So for example, yeah. So if you do raw input dot split, as we did in the previous question, you would end up with say some NM. And then for every value in that, because every value in this space separated list represents one polynomial coefficient, you convert that to a float and then put it in a list. Once I put it in a list, I will convert it to a NumPy array, which would be NumPy.array of the list. And then again, I will read from the input keyword. So raw input integer, which would be X. We could make this float too, actually, if the value is given float, it would be more generic. If we're restricting to integer, then we'll be only constricted to the integer values of X. Then all we have to do is numpy.polyval of r, comma, X. So that would be calculating the value of array at X. So which gives us 3. So there are three, 4 more questions here. So I have shared the link. Please give it a try. Again, these are fairly simple questions. So next week, I'll be talking mainly about pandas and going a bit deeper into that and why they are very useful in data processing and how you can use them to read some time series data from a CSV file or any other sort of time series data, and how you can represent different types of multidimensional arrays and time series data in the Panda data frames and for subsequent processing, and also how you can convert between Panda data frames and NumPy arrays, and also use libraries like Scipy for your optimization purposes. Yeah, that's pretty much it, I think. If Noor has anything to say. I think your microphone is mute.
Sorry about that.
Yeah.
Thank you so much, Sourav and Nandkishore. Thank you for the wonderful session. And yeah, thank you everyone for attending the session today. We have Tim Kara next Tuesday at 6 p.m. discussing about IoT security. Tim Kara is the founder of GeoOne. So please tune in on next Tuesday at 6 p.m. for the next talk on Internet of Things. And yeah, for the students who were asking the questions about the YouTube recordings and also about the Jupyter notebook files, we are trying to do our best to send you the YouTube recordings for the attendees, whereas for all the registered participants, we will be sending it post workshop sessions. Thank you so much. Yeah, and yep, thank you, Anne, for your engagement today. And the workshop team today we have is Sourav, Nandkishore, Priya, Satar, and myself, Noor. Thank you again.
Thank you.
Thank you. See you.
Thank you.
Thank you.
Thank you.